We'll start very shortly in 2-3 more minutes. In case if anybody joining has any doubts, feel free to ask right now, and then we'll get started in 2 minutes or so. Let me know if my voice is audible as well. We can do some audio testing right now before we get started. Also, we are trying to collect these sessions and make them available. Very shortly, they will be available in one place on a YouTube channel where you can. I think the worth will be that these sessions which we are taking are much lesser than what you will find in any other material. So, like I'm trying to cover the quant courses in maybe 20 videos of 1 hour each. So in the end, if you want to revise, it should be useful because you can quickly go through these 20 videos and you will know at least most of the concepts. Not everything is covered because we have less time here and we cover only on the key things, but it will be a good revision tactics at the end. So with that aim in mind, we are trying to aggregate these 20 videos. The challenge is that since I was trying to work on them during live session, the quality of those videos is not that great. So we'll see if we can do something to improve that. But that's the aim. So I'll just wait for 1 more minute and then we'll get started. Thanks, Manas, for letting me know that it's audible. So we'll get started now. Trigonometry in general is not a very important topic from CAT perspective, but it has applications which you might face. So from that perspective, it's important to know some of the things, but I would request don't spend a lot of time on it because things can be much more complicated, and if you spend time you can end up spending like months and still not get very comfortable on various kinds of question, and those questions would never come. So bear that in mind, and let's get started. Hopefully this will be an easy session. We won't do a lot of questions, but I'll cover some of the very fundamental basics, so you might be knowing some of it also. So let's start from the basics. What does sine theta, cos theta, or tan theta mean? So they're defined with respect to a right angle triangle. So if this is a right angle triangle, sine theta would be perpendicular by the base. Perpendicular by the hypotenuse. What am I saying? So sine theta was defined as perpendicular by hypotenuse. So whatever is this height divided by this height. So that's the ratio sine theta, perpendicular by hypotenuse. Cos theta is base by hypotenuse. If this is theta, this is your base, and this is the hypotenuse, cos theta will be base by hypotenuse. And tan theta would be perpendicular divided by the base. So this length divided by this length. So with this also you can develop a feel also for the various relationships we study. Why will sine theta never be greater than 1? Because the perpendicular can never be greater than the hypotenuse, right? Hypotenuse is greater than perpendicular and is greater than the base. So that's why sine theta or cos theta would never be greater than 1. Tan theta can have any value. Why is tan theta sine theta by cos theta? Because you can see hypotenuse will get cancelled and tan theta will become perpendicular by base. So this is how we define sine theta, cos theta, and tan theta. You should know this. You should know it very well. Like you should not be thinking what is what. Cosec theta, sec theta, and cot theta are also defined. I will be very surprised if a question comes which refers to these things, but still at least you should know. So cosec theta is just the inverse of sine theta. Sec theta is the inverse of cos theta. and cot theta is the inverse of tan theta. So these are the 6 ratios. Some people find it difficult to remember. So there is this sentence you might have come across earlier also. So it says some people have curly black hair tightly pulled back. So you just remember this sentence, and then it becomes sine is equal to P by H. So perpendicular by hypotenuse. Then this is cos is equal to base by hypotenuse. And then there is tan, which is equal to perpendicular by base. So it's just one sentence you remember, and you remember all the 3 ratios, and then you just need to remember what is the inverse of what. So if you have such problems, this sentence might be useful. So depends. If you don't have, then don't bother about it. But you should know all those, whatever we have discussed till now, you should know all that on your fingertips. Then there is these relationships, which also you should know. Sine square theta plus cos square theta equal to 1. Most of you know it, but you should also know how it comes. Just it's helpful. We saw just in the previous one. So sine theta is perpendicular by hypotenuse, cos theta is base by hypotenuse. You square and add. So perpendicular square plus base square for a right angle triangle will be hypotenuse square by Pythagoras theorem. So then it becomes h square by h square equal to 1. So very useful relationship. Please remember it in all forms. Sometimes you might want to replace sine square theta by 1 minus cos square theta. Whenever you see sine square theta and cos square theta, you should remember this relationship properly. There are these 2 other ones also. You can substitute the ratios that we studied in the last one, and you will get why this is so. For example, I can do the tan theta one. 1 plus tan square theta. One way is, if I write tan theta as sine theta by cos theta, this becomes 1 plus sine square theta by cos square theta. And then you add this, it becomes cos square theta sine square theta plus cos square theta. So the numerator becomes 1, and so it becomes 1 by cos square theta, which is equal to sec square theta. So just derive it once yourself also, because that way you get comfortable with these things. You don't need to derive it, but if you do it, you will become comfortable with what is tan, what is sec. Even if you forget it at the exam, you will remember. You will very quickly be able to derive it. So, but the first relationship is extremely important. This one you should know. Most of you know it, but you should know, like you know your name that well, that whenever you see something like that, you are able to connect. So these are 3 relationships. We studied some of these graphs when we were doing functions, but you need to know these graphs very well if you want to, because these can be asked. Function is part of questions which are asked, so you should know these functions very well. Let's look at sine theta. I'll try and zoom in a bit on it so that you can see it clearly. So sine theta, this is the graph, crosses 0. If you remember, we had discussed even functions and odd functions. Odd functions are symmetrical about origin. Whatever happens in first quadrant happens in third quadrant. So it's an odd function. For odd function, this relationship is true. Sine of minus x is equal to minus sine x. So sine minus theta is equal to minus sine theta. It also has a cyclical nature. You can see if I extend the graph, it will continue to replicate this way. So anything after 2 pi gets repeated. So you can say that it has a cycle of 2 pi, or sine theta plus 2 pi will be equal to sine theta. Okay, so you just need to know these 2 things, and then just the values where it reaches 1. At pi by 2 it is 1, at pi it's 0, at minus pi by 2 it's minus 1, and at minus pi it's 0. So between minus pi and pi, it reaches all the required values. Whatever the values it can achieve, it achieves them between minus pi and pi. Okay. In fact, it does that between minus pi by 2 and pi by 2 itself. So between here and here, you can see it covers all its values. But you need to remember these relationships more importantly, that sine minus theta is equal to minus sine theta, and sine theta plus 2 pi will be sine theta. And you also need to know how we arrived at these relationships. Similarly, cos's graph, cos is at 1 when the value is 0, then it declines. At pi by 2 it reaches 0, then at pi it reaches minus 1, and then comes back at 3 pi by 2, and then at pi it has come back to 1. So this is the graph of cos, similar to sine, except that it's shifted by pi by 2. this graph is even. If you have done your functions properly, and we discussed it while doing functions also, even functions are symmetrical about y-axis. So whatever you see on the right side of y is the same as what you see on the left side. So this is an even function. So cos minus theta will be equal to cos theta, which is the way you define an even function. F minus x is equal to fx. And that's why we spent so much time on functions at that point of time, so that we have less trouble now. So similarly, it also has a cyclicity of 2 pi. Things get repeated after 2 pi or 360 degrees. So cos theta plus 2 pi is equal to cos theta. Tan theta has a slightly different kind of a graph. Tan theta reaches infinity at pi by 2. So it's at 0 at 0, but at 90 degree, tan theta's value is infinity. Because it's sine theta by cos theta, and cos theta is 0 at 90 degrees, so it becomes 1 by 0, which tends to infinity. So it's tending to infinity at pi by 2, and at minus pi by 2 it's tending to minus infinity. So this is the graph. Tan has a cyclicity of pi, so tan theta plus pi will be equal to tan theta. Again, the graph is odd one, so tan minus theta will be equal to minus tan theta. I'm trying to also develop the intuition inside you that you can, just by looking at the graph, you are able to spot whether it's an even graph or an odd graph, and so on. So if you have any problems, please mention, comment. I'm happy to go slow. There isn't much to cover today, so there isn't any rush. If I want just to do the basics and do that properly, because most questions will be solved using the basics, but I think you will trip even in that. So these are sine, cos and tan. We know the graphs. We know whether they are even and odd. We know what is their cyclicity. What is the cycle like? So 2 pi for sine, 2 pi for cos, pi for tan. Cos 0 is 1, sine 0 is 0. So all that we have covered. Cosec, sec and cot, I won't draw the graphs, but I would leave you to try and draw these graphs. It would be an interesting exercise. It will check your understanding of functions and of trigonometry. So try and draw them yourself, how the graph would look for cosec, for sec and for cot. It's not very important from just this exam, like they won't show you a cosec theta ka graph or something, but if you draw these, you will get more comfortable with these functions also, and with functions in general. So try doing that. So try doing that. I think this will be something like this, and I would leave the other two to you. This will be something like this, and this will be something of this sort. So just try drawing it yourself, and you can compare with what I have drawn here. But it will be a good exercise for you to do. You can send it to me also, and I'll comment whether you have drawn correctly, or if you have doubts, you can message me separately as well. So, but then there are these relationships which you should know. Ideally, now we are getting slightly into the range where probably these things won't be required for CAT, but there is an off chance it might be. So I'm just covering this one. There are more relationships also. You definitely don't need to know. Like there are equations for cos 3 theta, sin 3 theta and all that kind of stuff that you definitely don't need to know. This one it's touch and go. So let's just cover it. At least the sin cos one you should remember. Tan you can leave also. So sin 2 theta would be 2 sin theta cos theta. And cos 2 theta is cos square theta minus sin square theta. The way it is derived is actually from the relationships you see at the bottom. So sin A plus B is sin A cos B plus cos A sin B. And cos A plus B is cos A cos B minus sin A sin B. So if I have to do, let's say, sin 75, I can write it as sin 45 plus 30. Let's say I know the values of sin 30 and sin 45. And then I can write it as sin 45 cos 30 plus cos 45 sin 30. So there is this formula. Now, if you find it difficult to remember, feel free to leave. It's not very important. I do not think there will be a direct application also, but there is an off chance there might be something. So just to be on the safe side, it might be worth spending some time. So this is how you apply these formulas. The way to derive the value of sin 2 theta is to just put b equal to a. So if I just substitute b equal to a in this formula, so this is sine a plus b. I just put b equal to a and I'll get sine 2a is equal to sine a cos a. I have put b equal to a plus cos a sine a, or equal to 2 sine a cos a. So that's the formula that we have seen on the top. Sine 2 theta is equal to 2 sine theta cos theta. So sine 60 will be equal to 2 sine 30 cos 30. Sine 90 will be equal to 2 sine 45 cos 45. So that's that. Similarly, cos 2 theta, you put b equal to a in this formula. If you put b equal to a in this one, you will get cos 2a is equal to cos square a minus sine square a. So that's how you get these formulas. So these two may be worth remembering. Tan one, let it be. You don't need to remember this. Probably you won't need this. So if you know, it's good. If you don't know, it's fine. Don't worry about this. Now questions, there are various questions out there on trigonometric identities which use different kinds of formulas to come up with different things. These are the kind of questions I was trying to warn you about. My sense is there is a rare chance that a lot of questions will come of this type. The chance is even lower that it will be a very difficult question if they ask something of this sort, because there are a lot of trigonometric identities out there and manipulating them might take a lot of time, and I don't think CAT will test you on that. But some basic ones will just have a quick look so that you are exposed to them. So here we have been given values of cos x minus sin x equal to root 2 sin x, and then we have to find the value of cos x plus sin x, and we have some options also in similar terms. So generally what you have to do is you would be knowing some identities, and then you have to try and experiment how you can get to a value. So here I know cos x minus sin x is equal to root 2 sin x. So I take sin x to the other side and it becomes cos x equal to root 2 plus 1 sin x. Or I notice that some of the options have cos x in there. So maybe I'll do like that. So I take sin x is equal to cos x by root 2 plus 1. So this I get from the first relationship, and then I have to find the value of cos x plus sin x. So here I'll just substitute this thing and I'll get cos x. If I take common, it becomes 1 plus 1 by root 2 plus 1. And then you can substitute to get 2 plus root 2 by root 2 plus 1. And this becomes root 2 cos x, which is one of the options that has been given. So there is no direct way. You will have to try and experiment with various things to see what works in what situation. Looking at the options helps in some cases as to what you are driving towards. But there are various questions like this. Again, my advice would be don't spend a lot of time on it. But remember the identities very well, because they are important. Whatever we studied till now, don't do more identities than that. There are a lot of them out there. Do not spend time on them. Your time is much better spent otherwise. अगर मतलब कुछ नहीं है पढ़ने को, तो you are better off watching cricket or going out than studying those identities for the preparation of this exam. Now this is a question. We are given this identity: sin 1002x plus cos 1002x is equal to 1, and x is in the range of minus pi to pi, both sides included. How many values can x take? Now this is the kind of question which may come, because it actually checks your presence of mind, etc. It doesn't need you to know a lot of formulas or anything, but your presence of mind is there. Maybe if you want, you can take a shot yourself also. I can pause for a bit in case you have any ideas, or if you have any ideas, you can comment also how you would have gone through this. Meanwhile, I'll write down the solution. So sin square x plus cos square x equal to 1. That's the relationship we know. So if sin x is equal to plus minus 1, in which case cos x will be 0. In those cases, if I increase the power to 1002, still that number remains 1 and the other one remains 0. Or if cos x is equal to plus minus 1, in which cases sin x would have been equal to 0. Here also, if you raise the power to 1002, this number will become 1 and this will become 0. So those are eligible solutions. But think about what will happen in other cases. Let's say sin x is some value and cos x is some other value between minus 1 and 1, and the sum of their squares is equal to 1. Now as this is a number whose value is between 0 and 1, so when I increase the power of that number will continue to become smaller. So you should get this, and that's why this is an intelligent question, because it tests your basic understanding of numbers and functions. Sin 1002x will be less than sin square x, right? It will only be equal if sin x is equal to 1 or minus 1. Otherwise, this number will always be less than this. And same way, cos 1002x will be less than cos square x. Same reason. It's a number between 0 and 1. If you increase the power, it will become smaller. So because both these numbers will be smaller and sin square x plus cos square x is equal to 1, sin this plus this can never be equal to 1, right? It will be less than 1. The only cases where this is possible is when these two numbers become equal, and that is when either sin x is plus minus 1 or cos x is plus minus 1. And those values between minus pi and pi will be minus 180 degree or minus pi, minus 90 degree, 0, 90 degree and 180 degree. So total of 5 values. So these are the 5 values for which this relationship is justified. For no other value, this would be possible. Is the question clear? Prendu, I have come up with 5 values. So I don't know how you came up with 2. Check where you are making that mistake. Early you should not. The answer should be 5. I think I'm not getting anything wrong. So you'll have to check for plus 1 and minus 1. And cos x also plus 1 and minus 1. And the range is minus 180 to 180. So you will have 0, 90, 180, minus 90 and minus 180. So all those 5 values will be covered. Yeah. So this is a good question. Basic application of functions, basic application of identities, and some knowledge of range, etc. So I would expect such questions might come, but don't go for anything very fancy. There are these common questions in max and minima. Might be worth having a look. Good questions. So what is the max value? Let's do it like this. What is the maximum value of sine theta? It would be 1. Minimum value minus 1. What is the maximum value of sine 2 theta? Now it's still a sine function, right? And sine function can never go beyond 1. So this doesn't change anything. Still the maximum value is 1. The minimum value is minus 1. If I did mod of sine 2 theta, then what would change? Now the maximum value is 1, but the minimum value cannot be negative. So all the negative ones turn positive. So the minimum value becomes 0. Graph wise also, if sine 2 theta's graph was this, mod of sine 2 theta's graph becomes this. So the part which is below moves up. We did all this also in function transformation. If you didn't, you should revise that. But so the maximum is 1 and the minimum is 0. What is the maximum and minimum value of sine theta plus cos theta? So as a lot of you know, the way to do this is, let's assume y is equal to sine theta plus cos theta. Then if you square this, this becomes sine square theta plus cos square theta plus 2 sine theta cos theta. And this first part is 1, so this becomes 1 plus 2 sine theta cos theta, and we just saw before 2 sine theta cos theta is the value of sine 2 theta. So this is 1 plus sine 2 theta. and sine 2 theta has a maximum value of 1 and a minimum value of -1. So this function 1 plus this function will have a maximum value of -1 and a maximum value of 2 when sine 2 theta is 1 and minimum value of 0. So this will have minimum of 0 and maximum of 2, and since this is y square, y will range between minus root 2 to root 2, because if y square is 2, then y can be minus root 2 and y can be plus root 2. So the value for sine theta plus cos theta will be equal to minus root 2 and root 2. Now if you are finding it difficult to follow, let me know. I can revise this, I go through this again, but it's probably because you are not very comfortable with the identities. That can be the reason why. There is another way to look at this, and we should look at it because we will run into that thing over here. Sine theta plus cos theta, we can write it as 1 into sine theta plus 1 into cos theta. If we multiply by and divide by the square, if we multiply and divide by 1 square plus 1 square or root 2, we get 1 by root 2 sine theta plus 1 by root 2 cos theta. This can be written as sine 45 and cos 45. So we can write this as also root 2 cos 45 sine theta plus sine 45 cos theta. And using this, you can write this as root 2 sine theta plus 45. So the value in between has a maximum of 1 and -1. We are multiplying it by root 2. So the maximum minimum becomes root 2 and minus root 2. So this is another way to do it. Generally, the way to remember is for such things is a square plus b square under root is the maxima and minima. If it is a sine theta plus b cos theta, we'll come to this one. Let's just complete this and we'll come to that one. If a mod section is applied, then the negative turns positive. So this becomes root 2 maximum, minimum becomes 0 because you cannot go below 0. What do we do with 3 sine theta plus 4 cos theta? Same thing that we did earlier. We multiply it by a square plus b square, where a and b are 3 and 4. So if you multiply and divide by that, you get 3 by 5 cos theta, sine theta, plus 4 by 5 cos theta. And then these will be some values or some alpha for which this is cos alpha and this is sine alpha. So you can write 5 into sine theta plus some angle alpha. You don't need to know alpha and everything. You just need to know that this is a sine function. Overall, this is just sine of some degree, and which means this number will have a plus maximum of 1 and minimum of -1. So the total expression will have a maximum of 5 and a minimum of -5. And that gets us almost a relationship also. If you have to do it for a sine theta plus b cos theta, the maximum value is root a square plus b square under root, and the minimum is minus root a square plus b square. Which in this case becomes equal to 5 and -5. And if you add 7, that doesn't change anything. So leave this number. The maximum value of this function is 5. So the maximum value of total is 7 plus 5 equal to 12. And minimum value of this function is -5. So the minimum value is 7 minus 5 equal to 2. So I hope you understand. I've gone through this a bit quickly, but if you are not able to follow, please raise your voice and I'll be happy to explain it again. But if you revise it, it should be fairly easy to understand. These are the values you should remember. A few relationships also. Sin 90 minus theta is equal to cos theta. Cos 90 minus theta is equal to sin theta. So this is basically the same thing. And tan 90 minus theta is equal to cot theta. So you are only going till 90. You don't go after 90. I don't think they'll ask beyond 90 from in CAT. These values you should remember. Sin 30 is half, and sin 60 is root 3 by 2, and sin 45 is 1 by root 2. So these three you should remember. and cos 30 becomes sine 60, so it's the same value, root 3 by 2, and cos theta is 1 by root 2, sine 60 is 1 by 2. Tan is just a sine by cos, so it is 1 by root 3 and root 3. So these values, and then these three are reverse of what we have done earlier. So it's not very difficult to remember. You should remember these values because you will come across these in height and distance related questions, which we'll do very shortly. So for that purpose, you should remember all these values, and it's not very difficult to remember also. Height and distance is an easy topic. You might get a question. If you get a question, you should solve the question because others will solve that question. So if you miss, it will be a big loss for you. The height of a pole, I'm just taking a very basic example to start with. The height of a pole is 10 meters. From top of the pole, when you look down at 45 degrees, you see a point. How far is the point from the base of the pole? So what we are saying is that this is a pole whose height is 10 meters. And from here we are looking down, and we look down at an angle of 45 degrees, and you see a point. So how far is the point from the base of the pole? We need to find this distance x. Very easy. If you know tan 45 is equal to 1, which is the ratio of perpendicular by base, which is equal to x by 10. So using this, you can get x is equal to 10 into 1 equal to 10. So very basic example, just trying to introduce height and distance. Let's see a few more questions. Most of them are very similar. You just need to analyze the situation, then you can apply values and get the answer. So let's read the question. Monkey is climbing a pole at a uniform speed. Boy standing on the ground at some distance from the pole observes that it takes 5 minutes for the angle of elevation of the monkey to change from 30 degrees to 60 degrees. If the boy starts walking towards the pole with the same speed as that of the monkey, how much time will it take to reach the base of the pole? So what is the situation? So most of the work here is in getting the situation correctly. After that, there isn't a lot to do. So let's see what this is saying. It's saying there is this pole. So this is a pole, and a monkey is climbing this pole. Now, the boy is watching from here at some point, and at some point he was watching at an angle of 30 degrees, and after 5 minutes the angle changes to 60 degrees. So the monkey climbs this distance in 5 minutes. Okay, and then the boy starts walking in this direction towards the pole. How much time will it take to reach the base of the pole? How much time will it take to reach him here? Now let's say this distance is x. Okay, this distance is x. So we know this distance has been traveled in 5 minutes. If we can get this in terms of x, we should be able to calculate how much time will it take for him to travel that distance. So that we can get very easily. Tan 30, so let's say tan 30 is what? Tan 30 is 1 by root 3, and tan 60 is root 3. So tan 30 is 1 by root 3, which is, if I mark this as AO, which is equal to AO by x. So implies AO is equal to x root 3, x by root 3. So this distance is x by root 3. And similarly, tan 60 is root 3, which will be, if this is B, BO by x, and then therefore BO becomes x root 3. So the total distance, this one, is x root 3. So the monkey only covered x root 3 minus x by root 3 in 5 minutes. So how much time will the boy take to cover x distance? He's traveling at the same speed as the monkey. So for x distance, he will take 5 by root 3 minus 1 by root 3. And then you can simplify however it's needed. I think it will come to 5 root 3 by 2. So this is how you solve. So generally questions are easy. I would recommend that if you get a question in mock or something, try to solve it. You should be in the practice of not missing out on questions on height and distance if they come. Let me know if I need to stop anywhere, but there isn't a lot of difficult things going on here. It's mostly application of basic trigonometry, so you should be able to. This is even easier. So there is a river, and A is here, B is here, and there is a ship in between. Okay, and when A looks at the ship's top, he is looking at an angle of 60 degree. And when B looks at the ship's top, B is looking at an angle of 30 degree. The height of the ship is 30 meters. So this is 30 meters. What is the distance between A and B? So we have to find this distance. So again, you can very easily do things. Let's assume this is X and this is Y. Tan 60 equal to root 3. And that's why I said you need to remember these values because they come fairly often. Equal to root 3 is equal to 30 by X, which will imply X is equal to 30 by root 3 or 10 root 3. And let me just clear this. Tan 30 is equal to 30 by Y and is equal to 1 by root 3, which implies Y is equal to 30 root 3. This is 10 root 3. And therefore, the distance, which is X plus Y, will be equal to 10 root 3 plus 30 root 3 or equal to 40 root 3. So fairly straightforward. If this kind of a question comes, it's a real bonanza. Even for height and distance, this is a slightly easier question than what you expect. This one is more in line of what you would get. This is not very easy, but it's doable and you should be able to do it within 2 or 3 minutes, which will be assigned in the exam. Let's see what the question states. There are two flagpoles, A and B, of height. So there are two poles, A. So this is A and this is B, and their height is given. So this one is 15 root 3 and this one is 30 root 3. Okay. There is a point on the ground from which, if you look up at both, you get 60 degree on both sides. This information is given. Then we are to find the maximum possible distance between the top of the two flagpoles. So what is the distance between this and this? What is this distance is what we are being asked to find. So Christ is saying, will this video be available for future reference? Yes, it will be. It will be available just on Facebook, so you can watch it later also. And that's why I go a bit fast also, so that if you don't follow, you can always revise later on. So you don't need to be making notes, etc. right now. But my advice has always been that you should spend 2 or 3 hours revising this video later on, where you write down everything, solve each of the question yourself, then see how I have solved, and do that at least twice. Then you will become an expert on the topic. So that's there. Let's see if I mark this point as O, this point as A dash, and this point as B dash. A dash O, which is equal to tan 60. So let's first find out this distance. What we'll do is we need to find this particular distance here. We'll try and find this distance. We'll find this distance and then apply Pythagoras theorem to get that distance. So let's apply the tan formula to this particular triangle. Tan 60 is equal to perpendicular by base, so 15 root 3 by AO, which is equal to root 3. So from here we get AO is equal to 15. And similarly, we apply the same formula in this side and you will get OB dash, A dash O is 15, OB dash is equal to 30. You just apply the same formula again on the other side and you will get the same thing. So we know this particular distance is 45, 30 plus 15, or this distance is 45. So we have got one distance. We need to know what this particular distance would be, but this we anyway know. One pole is of height 15 root 3, another is of height 30 root 3. So this will be the difference of the two, which will be 15 root 3. Right? Because this pole is still 15 root 3, so the remaining distance will be the other ones. So 30 root 3 minus 15 root 3 or 15 root 3. So we've got 45 and we have got 15 root 3. So if you need to know this particular distance, you can just apply Pythagorean 45 square plus 15 square into 3, and then you can simplify. This becomes 15 square. If I take 15 square common here, this is 9, this is 3, so this is 15 square into 12, and then you take 15 and 4 out, so this becomes 30 root 3. Now, I did it fairly quickly. You should also do it fairly quickly. These things do cost time, so if you are able to do it quickly, you might be saving some time. I hope I did it correctly also, but otherwise, yeah. So 30 root 3 is the answer here. You needed to do some work, but this wasn't work which would have been wasted. As soon as we started the question, we knew we would get to the answer, and that's the good thing about such questions. Once you understand the question, you will get to the answer. You might need to do a bit of extra work, which is different from a lot of other questions, say algebra questions or geometric questions, where you do not know whether you will reach the answer. But here you definitely know that how to will get to the answer. So if you get questions on this topic in the exam, definitely attempt them. You won't get a lot. Maybe one you will get, maybe you will not get that also, but still worth the effort to. Now all the questions which sound like height and distance need not use height and distance. So that's also a warning, and just be open to other options also. We'll do a few questions like that. So the question here is, there is a boy of height 100 centimeter. He walks away from the base of a lamp post. So this is a lamp post. Let me just bring it. Yeah. So this is a lamp post. And the boy walks away from it. The lamp is 42 meters above the ground. So this height lamp is 42 meters. And the boy had walked at a speed of 1.4 meter per second away from this direction he has been walking. And we need to find the length of the boy's shadow after 40 seconds. So in 40 seconds at the speed of 1.4, he would have traveled 56 meters, right? So this distance is 56 meters. And the light, if it's coming from here, it will cast a shadow of this length. This is the length of the shadow. Let's call it x. So now you don't need to apply any height and distance or anything. You can use what you have discussed earlier. These triangles would be similar. This is 90. This is 90. These two lines will be parallel because it's 90 to the same line. And since they are parallel, these angles will also be equal. So these two triangles are similar. This triangle and the bigger triangle are similar. And because they are similar, you can use their sides will be in the same ratio. So from the smaller triangle, this length, which is x, divided by the bigger length, which is x plus 56, will be equal to the vertical length. So this length, which is 1, divided by this bigger length, which is 42. So the only effort that was needed was to visualize it correctly. Once you have done that, now it's a fairly straightforward question. 42x is equal to x plus 56, or x is equal to 56 by 41. So this is the length of the shadow. And solving it hardly takes a few seconds, but you need to understand the question, draw the images correctly, and then go ahead and solve. So that's there. I think I have a very similar another question. So this one is fairly similar. You have the question on your screen. You can read it later on if you want to revise this, but I'll explain what the question is. There is a lamp post which is 6 meters high. So there's a lamp post, and then father and son are standing in the same line. Father is 1.8 meters and son is 0.9 meters, and both their shadows are ending at the same point. So their head are coming at the same point. So that means that the ray of light that's coming from here is crossing this also. So both of their shadows are reaching here. Once you get this diagram, then the question is easy. It's also given that the father is 2.1 meter away from the lamp post. So this distance is 2.1 meters. And then you are asked how far is son standing from his father. So we need to calculate this particular distance. We need to calculate this. So let's assume this distance to be y and this distance to be x. And now again similarly we have three similar triangles. So you can write equations accordingly. Let's say if we were just to take this one and the bigger triangle, you will notice the ratio of the height of the poles 1.8 by 6 is equal to the ratio of the distances. So the distance here is x plus y divided by x plus y plus 2.1, right? And from here you can solve for x plus y. Just keep x plus y in the same place. Let's say I replace x plus y with t. So then it becomes t by t plus 2.1. And then you can solve for it fairly quickly. Let's do it 3 by 10. So this is 3t plus 6.3 equal to 10t, or t is equal to 0.9 equal to x plus y. So this length is 0.9. And again you can apply the same formula to the smaller two triangles and you will be able to get that answer. So if I try to apply it again, 0.9 by 1.8 is equal to x by 0.9, and that gives me x is equal to 0.45. So the total length from here to here is 0.9 and the length in between is 0.45. So this length is 0.45. So the other part, the distance between father and son, will also be 0.45. I went a bit quickly, but if you didn't understand, again let me know. I'll again go through this. It will hardly take me a couple of minutes, but if it is easy and understood, then we don't need to go over this again. In general, solving these questions is easy. The only tough part is getting the diagram correct. Once you've got the correct diagram, it should not take you a lot more time. It should be like 15 seconds, 30 seconds job overall. There is this question with which we'll close. This is the final question for the day. A ladder leans against a vertical wall. So this is a ladder which is leaning against a vertical wall. The top of the ladder is 8 meters above the ground. So this distance is 8. When the bottom of the ladder is moved 2 meters further away from the wall. So right now let's say it is at x distance. Now when it moved 2 meters further away, when it's put at x plus 2, the top of the ladder rests against the foot of the wall. So this top comes down and comes here. And it becomes like this, which tells us that actually the length of the ladder is x plus 2. So this becomes x plus 2. So now we have 8x and x plus 2. So it's actually just a Pythagorean theorem. 8 square plus x square is equal to x plus 2 square. And now for people who are more observant, they don't even need to solve because they would know which Pythagorean triplet satisfies this relationship, that 8 square plus a number and a number plus 2 square. But if you want to solve, you can solve also fairly quickly. You just take x square to other side, a square minus b square, you apply a minus b and a plus b, and you will get x plus 2 minus x, which will be 2, and x plus 2 plus x, which will be 2x plus 2. So you can take 2 out and you'll get x plus 1. So x plus 1 is 8 square by 4, or x plus 1 is 16. So x is equal to 15 and x plus 2 is equal to 17. So you are asked the length of the ladder, and length of the ladder is 17. So again, easy question. The only task is to somehow get the diagram correct. After that, it's not very difficult. Even earlier, it should be considered an easy question. So I'll stop here. We had a short class because the topic is relatively easy, but if you find it difficult, then you should spend some time. Next class onwards, we'll work on circles, and quadrilaterals after that. But I think that's mostly it. So thanks for joining. If you have any feedback, most welcome. As I mention every time, and please revise the class. Even if you thought it was easy, at least spend some time revising the class so that easy things become very easy, and in the exam you spend much less time doing all the thinking. Thank you.